In today's session, we're going to continue on the concept of synchronous management. Today's session is going to be on principle number 12, which talks about transfer batch. And the transfer batch need not, and many times should not, be equal to the process batch. So let's dive into this subject in a little bit deeper. First of all, let's define different batches. There's different activities that go on in the organization that define the batch. So first of all, the order size, that's typically what the customer is ordering under one purchase order. So you could have multiple line items on one order, and that line items make up the order that the customer's purchasing from your organization. Now, once we get that order, we can create a work order. So a work order is the items released to be processed under one manufacturing order. So in some cases, keep in mind that multiple customer orders could be grouped together to create one work order. Or it could be one line item creating one work order, depending on how it works in your organization. Next is the process batch. So that's the amount of work that's going to be processed at a resource before the resource changes to another product. So keep in mind, multiple work orders could be grouped into a process batch. And then lastly is the transfer batch. So the transfer batch is the amount of work that's transferred from one operation to next within the same run. So I can have a process batch of 10,000 units, and then after every 1,000 units are produced, I can transfer them to the next operation. So our process batch is 10,000, my transfer batch is 1,000. So now let's talk about traditional thinking around batch size. So the original method for determining batch size is what's called EOQ, which is economic order quantity. And how that's determined, it takes the total setup cost and amortizes that setup cost over the number of pieces that are produced. So the more pieces that I produce, the lower the total setup cost per piece. Then we have the carrying cost to carry those items, which means how much money we have tied up to store that, count that, hold that inventory. And then when we take the curve of these two costs, we get the total cost here in this blue curve. And what you'll see is that there's a minimum total cost, that's the economic order quantity. So in this case, the batch size of 3,000 reduces our total cost, and that's our economic order quantity of 3,000. This works great in traditional cost accounting, but one of the things that we want to understand is we don't want to allocate cost to the product. So when you don't allocate cost to the product, that changes your mindset. Let's look at the impact of batch size reduction. So in this case, we have a batch of 10 items that go through 3 process steps. It takes a minute to process each item on each process. So if we look at the total time to complete this order, it's 10 minutes on process A, 10 minutes on process B, 10 minutes on process C. So a total of 30 minutes to get this order through the system, and that's with no setup time. If we have setup time between the operations, we're going to add that to the total time. And we can see our first good piece comes out after 21 minutes. So we got 10 minutes on process A, 10 minutes on process B. Piece number 21 comes out after 21 minutes. Now, if we move to a synchronous flow concept where we reduce the batch size, so I don't care if you're reducing the process batch or the transfer batch, it has the same effect. And what happens is we produce the first item on process A, we move it to process B, then the process 3, and our first good piece comes out after 3 minutes, and the total time to complete the order goes to 12 minutes. So when we reduce the batch size, we have significant impact on flow. So our goal is to improve flow, not reduce cost. So let's look at the effects of reduced batch size. So if we reduce the process batch, what we see is yes, there's going to be an increase in change over time. So if we're going to do smaller units of products, before we change over, we're going to see an increase in change over time. Well, we have techniques to reduce changeover using the SMED methodology. It'll also increase the transportation time. So the amount of time that we're moving parts through the plant is going to increase. Also, we're going to reduce the lead time to process the order. So the time from start to finish, like we just showed in the previous slide, is reduced. We're going to reduce quality issues because we're not going to have a bunch of stuff that are suspect. When we have a quality issue, we're going to find it immediately and address it, so we have less items with quality issues. Of course, our work in process inventory goes down, which frees up cash. It also reduces our costs. So a lot of people think that big batches reduce costs. It's actually the opposite. It increases costs. So by reducing batch sizes, it actually reduces costs because quality issues go down, expediting goes down, overtime goes down. We also get quicker response to our customer demands, so we can respond much quicker to our customer requirements. And then here's one that I didn't understand was a benefit until I actually saw it happen: the risk of change orders from the customer. So if you reduce the lead time, the likelihood of the customer making a change within that shorter lead time gets less and less and less. So if we think about it, if I have a 6-week lead time through production, the chance of the customer changing that priority or changing that order in 6 weeks is a high probability. If I can reduce that to 6 days, the likelihood of that change goes down significantly, which reduces significant chaos. Now, if we look at transfer batch, we have all the same improvements in transfer batch, except the one thing that's different is we don't reduce the process batch, and so setup time stays the same. So the only difference between transfer batch and process batch, the effects, is one affects setup time, the other one doesn't. This one increases transportation time, but both of them have positive effects for the organization. So that's our session for today. Of course, the goal is to try to drive down to the smallest batch possible. A batch of 1 is ideal. Of course, that might not be totally optimal in some organizations, but that's our goal, to drive to that level. In next week's session, we're going to talk about process batch and the effect of the process batch as it moves through the production system.